Casey Caruso and Jules Urbach with special guest Sam Hogan.
Hey, hi everyone. Am I here?
Yeah, perfect.
All right.
Yeah, you two go there. Okay, great. Well, this panel is on crypto AI, and I'll let both of you introduce yourselves, and then we can dive in. But my name is Casey, and I run a frontier tech fund, and previously was an engineer at Google, and most recently was an investment partner at Paradigm.
I'm Sam Hogan. I'm the founder and CEO of Kuzco, which is a decentralized LLM inference network.
Great. I'm Jules Urbach. I'm the founder of the Render Network. We do decentralized GPU compute and rendering on chain.
Awesome. I love the concision there. Okay, so let's start off with a more broad question, just in terms of both of you, your own vantage points. Why is this space or intersection even a thing right now? And how does crypto need AI, or vice versa?
I'll give it a first shot. I think, there's obviously the AI space has absolutely exploded. I think that the introduction of LLMs and generative AI has, correctly positioned people to consider the world is changing rapidly. Jobs will be replaced with other types of, of automated services, but also there's opportunities for new kinds of careers and new kinds of technologies. I think one of the greatest issues with AI is provenance. Like when you're seeing something, just look at the issue with deep fakes or whether information that's being sent by an LLM is correct. Like where do you check the ground truth for that? And our company has been focused on the visual aspect. Like we're a company that built tools for artists. We have Disney and Warner's as investors. We create tools that allow people to build cinematic pieces that are in films, or also just NFTs. Like Deepin is one of our artists using our tools. If you know how the thing was created, the render network takes all the pieces for an image, whether it's AI-driven neural or just traditionally CG or coming from the real world, and it creates a receipt for that. We started on Ethereum, moved to Polygon because of the transaction issues, and then Solana. And we fully moved to Solana. And every time that you're using the render network for production, whether it's a live service or an offline piece of media content, you can see that piece of content was built with these pieces. There's a receipt for that. And as the world of AI automates things, as you have agents that are doing all these things, and the intermediate steps for how you're seeing a piece of content, how to provide the authenticity for that, having the receipt of how it's built is fundamental. And I think the crypto aspect of this is great for that. I mean, the idea of NFTs initially was that you could, as an artist, say, this is my creation. Granted, I think it started too simple. That's one of the reasons why I think NFTs probably have another life down the line, where you can say, my NFT is I'm contributing this training data or this piece of a service to an AI output. On the other side, I think the cost of AI inference, right, running AI jobs for things like ChatGPT or Midjourney are high. Training is even higher. And so the concept of Deepin with GPUs, where there's a lot of latent compute power out there. I mean, we target 4090s, high-end NVIDIA gaming cards that are in the hundreds of millions, right? And the way that I see AI going is that you will, certainly for generative media, you're going to go to a lot more inference than training, and that means you can run on much, probably very high-end consumer cards, but like the rumored next NVIDIA consumer card will have 32 gigs. Apple is shipping GPUs with 128 gigabytes of RAM, right, in my MacBook. And so you're going to see a lot more AI workloads that can be done on consumer cards, and if those can be brought into Deepin networks, and you can pay out the way we started, right? You're mining Ethereum? No, switch to Render. We're going to pay you, more than what you would make mining Ethereum, and less than what we pay Amazon for the same workload. That's a really holistic model that I think we want to see happen. So that's where I see, at the first layer, AI and crypto converging in a positive way.
Okay, and I want to come back to Deepin after, but let's stay on the first question, and then I want to come back to that after.
Yeah, I think that's a great overview. Provenance, sort of capital formation via Deepin. Crypto figured out this sort of coordination layer, how to coordinate capital in productive ways. And now that AI is sort of starting to scale out, and you need to do these massive, data center builds, you have to be sort of clever about how you finance some of that, and you can use crypto as a mechanism to sort of spread the cost across stakeholding parties. So we spend a lot of time thinking about that, and I would say that Provenance is also a really interesting AI crypto crossover.
Yeah. Okay. And then agree with both of that. So going back to Deepin for a second, where do you think Deepin, or what do you think Deepin's doing today that we couldn't accomplish without the centralized providers? And you kind of touched on this, both of you, in terms of the crypto economic schemes. But just to be more concrete, what do you think it's really enabling?
Sorry, can you repeat the question?
Yeah, just on the Deepin side, where do you think Deepin's shining in a way that centralized providers can't?
I mean, I think the interesting with Deepin's trajectory in the crypto space, in the Web3 space, is that there is a lot of money going into centralized, services like CoreWeave, for example, which I think started as a, blockchain company and then moved into, very cleverly into everything that was being done on AWS, and then really, with investment from NVIDIA, built itself into a powerhouse. It's like it's insane. If you're going to do a Deepin project and you're competing against CoreWeave, it's tough because CoreWeave has a ton of H100s, all this infrastructure. It's almost like the world of AI today for high-end, training isn't a good fit for decentralized approaches like ours, but that is changing. I think that you look at some of the recent results from O1, that this is OpenAI's new model where, it does a lot more reasoning, it does a lot more thinking, so it gets the answer right. Takes longer, but there's an interesting graph that Ahmad actually, one of my advisors on Render, who created Stable Diffusion Stability AI, is pointing out that the cost of training in one of those really high-end, like CoreWeave data centers or what Azure is providing OpenAI, you can flip that and you can run it in runtime, and that compute can figure out the same result by running on inference, and you don't need to do the training, and that inference can run on much cheaper hardware. So as the world moves from doing high-end training in high-end data centers towards more inference, and that's where I think even OpenAI is heading, that plays better into into Deepin narratives like ours, which are dependent on the swath of consumer cards or even mobile devices now that Apple is providing almost could be nodes for our system going forward in the future.
Mm.
Yeah, I think there's a bunch of interesting ways to kind of look at this. Like training versus inference is one of them. If you look at total compute used for training over the last decade, it's much larger than the compute that was used for inference, which makes sense because you have researchers that are doing a lot of training runs and they're kind of experimenting. And now we have a world where those models are actually useful. And so you move more toward how do we actually get these models to do work for us? And then that's where inference comes in. And so maybe 10 years ago you have 99% of AI compute going towards training. And pretty soon, I think in 10 years, we'll probably be close to the other direction where you have 95 or 99% of AI compute going toward inference.
Yep.
And inference is a much easier type of job to complete. For training, you need these really centralized clusters. They need to be networked together, very kind of low latency, high bandwidth connections that NVIDIA specializes in. Inference is a lot different where you're processing one job at a time, and the bandwidth that you need is pretty low. So you can take a MacBook or a 4090 that's somewhere in the world and send work to it for it to complete, and it can send it back. And you may not get the same performance that you would get from a really centralized like H100 provider, but for most jobs it's still going to be effective, especially if you're doing these sort of asynchronous image rendering or animation rendering workloads. Yeah. So I think there's a bunch of interesting ways. Deepin in general, like more broadly, it sort of allows maybe somebody who only has a MacBook or only has a GPU to put them to work in productive ways with only a few $1,000s of investment versus needing a $100 million data center to participate in this economy. So it opens up a lot of participation from your kind of everyday people, and also allows for like this lower tier of hardware to be productive.
On the distributed inference versus training part, it sounds like both of you are more excited about inference, but what would you say to somebody that has been following the distributed training with the new thing that recently came out? Google's also working on it. I mean, you kind of talked about it, how you need like the co-location of servers, but we're also making some good progress there. So what keeps you more excited about inference beyond that?
Yeah, I mean, I think distributed training will be really cool, and it sounds like people are starting to figure it out. Noose Research, Prime Intellect is also working on this.
Yeah.
Google's working on this. CoreWeave actually might be working on this. So there's big players, well capitalized, really sharp research organizations that are putting a lot of time and capital into figuring this out. I still think long-term inference is a much larger market.
Yeah.
So you might be able to do distributed training, and you can maybe you're doing distributed training not on 4090s and MacBooks, but you're actually doing it across data centers. So rather than needing to build a 100 gigawatt data center, you can kind of network together 100 single gigawatt data centers and do training, do distributed training that way. But yeah, long term, I think inference is probably a much bigger market opportunity.
I also wanted to add to that. I mean, there's going back to where crypto fits into this as well. As you're from an LLM perspective, right? If you have a long context window and you can feed it hundreds of books when you're asking the question or as part of the question, right? Then that's not part of training, and that goes into the inference side, the compute side. What I find interesting about that is that if you're then going to have a payout to somebody whose book is being used in the question, right? That's something that you can then see in inference much more clearly than all this crazy stuff that's baked into a base training model. And I think that also means that payouts for people's content or people's things that are used during inference versus all, we scoop up the entire, universe of information and here's this base model. I do think that the more and more things are going to move to the inference side because it's easier. It also, in some ways, is a little bit more private in that you can kind of feed data that you want, right? And if you want to have private data that's trained, I mean, rather than training it, just feed it into the system. And you see that with image generators, right? You have LoRa's that are popularized by things like Flux and Stable Diffusion, where you give it 20 images and that object becomes a neural object that can then be used. And those LoRa's can even be transferred or monetized. And that doesn't require retraining the whole model. These base models, at some point, I think the competitive vectors in this industry are going to force people to not do as much training, but create something that is able to work in runtime with much more flexibility, and then give a lot more players in this space the ability to create, to fine-tune these things or to create LoRa's that are almost like you're selling an asset. You're selling a piece of IP, and that's true for video models, image models, 3D models, and of course, in our case with render, there's a lot of intersection with production, with studios, with IP. We're working on a project with the Star Trek IP right now, which has been going on for years, and it is something. It's interesting. You're seeing a lot of headlines where there's just all this angst around what's going to happen with the actors, what's going to happen with the studios themselves. Lionsgate just licensed all of their movies right to Runway. I love the Runway guys. I think them, Luma, they're doing great things in video generation, in the video generation space. But the data that it's trained on, ultimately. I think some of the studios are also being reticent about providing that data. They don't want to necessarily have OpenAI's Sora, compete with Disney movies if you give them all that IP. But I don't think the world is heading in that direction, and I think Deepin's a big part of that, because if you want to do something, whether it's user-generated content, which might even have, a smart contract that decides how that gets, utilized, or you have a licensed piece of content being done with Disney's IP, there's probably a way for Disney to make money if the inference that's using to run that output is, it's effectively loading that at runtime, and it's not sort of lost in the shuffle of, a pre-baked model. And I do think that all of those things are also pointing towards another important inflection point, which is world models, right? That's what Sora was kind of hinting at when OpenAI put that out there, where instead of just generating videos, you're generating an actual simulation, which means at the very least, you can play that, what you're seeing as video, as a video game. So when Jensen talks about the future of video games and rendering being neural versus ray tracing, he's talking about that. But again, once you have this simulation, then you have so many other aspects. I mean, all the things that NVIDIA's doing with Omniverse or digital twins could be moved to those kinds of models. And it's sort of the Uber model. Once you have a world model and a simulation system, then even LLMs can train themselves not just on text, they can run simulations, learn from that just like we do.
Yeah.
And that leads to the holodeck, which is, for me, a huge end goal that we want to see happen in our lifetimes.
Yeah, the progress we're going to see from multimodal is insane. And I think the VLM future is really interesting, and I agree on the world models. Also on distributed training, I agree. I think it's beyond just that maybe inference is more popular. It's that distributed training is such a small set of users and customers that from a business standpoint, it's a really hard business to build. Even if we can accomplish the tech, I just think that it's much fewer people are obviously going to be training models, and the cost-benefit analysis of doing it in a distributed way might not pan out. But I want to focus on inference for a second. Another rebuttal that I hear a lot is that right now we're in this temporary situation where supply and demand don't match. Much better chips are coming out, and so the delta is going to close. And distributed inference isn't even going to make sense in the future because we're going to have such better supply that it's not going to be worth it anymore. And this is a temporary moment in history where it does make sense. And I'd be curious, both of your takes on why the opportunity in distributed inference is still going to exist in, call it, 2 years, even when better chips come out.
I can start. Okay. Yeah, so, I mean, we spent a lot of time thinking about this. I think, like, you can kind of, I sort of think about inference as, like, energy production. And I think, you know, going back 100 years or whatever, you could say, like, oh, you know, we have all these power stations, like, what are people gonna use them for? Or maybe you're building power stations, like, what are people gonna use them for? And it's really hard to predict that 100 years later we'd have, you know, cameras and lights and, like, iPhones and everything. But energy, like, fundamentally is the thing that allowed us to explore, you know, all those new technologies, electronics, right? And I think inference is sort of the same thing. If energy 100 years ago had stayed really expensive, we probably wouldn't have tried to make cameras and all these other things because your average person just wouldn't be exposed to it. They wouldn't have access to it. And so as you think about more supply coming online, well, if you have a way to sort of like harness that supply globally, and have, like, you know, kind of weird network topologies where you have like H100s and, you know, A100s down to like MacBooks, and you can deploy workloads to them, more supply is good because all that does is put downward pressure on the price, which allows for more experimentation. You know, you can build different products profitably and run them as businesses. So yeah, I mean, I think more supply is generally a good thing. I don't know that there's really a limit on that. I think the hard question will be for data centers who, you know, are focused on inference. You know, they'll have to figure out how they can compete with somebody who, you know, has different sort of economic fundamentals than they do.
Yeah. Like the OpEx is just better for bigger data centers, yeah. Like the Googles of the world.
It's a fascinating, you know, question because, of course, you know, NVIDIA is dominant in this space, in the data center space, and it's, you know, our experience, the reason why I built Render initially was we were doing CGI renders on AWS, and we were one of the first. Jensen put me on stage to talk about, you know, putting Octane, our render, in the cloud. And at that time, we knew that GPUs were going on AWS. That didn't exist before then, really. We even helped AWS design the G2 instance, which was the very first data center GPU with an NVIDIA card. And so it turned out, you know, those cards weren't that much better. This is all before AI really took off. Those cards weren't any better than what you could buy at Best Buy, but they were 10 times more expensive. And NVIDIA had a EULA, right, that says you can't use, you know, a GeForce card in a server. And that meant that Amazon and Azure, when they followed, and Google Compute always had to pay more, even just for a traditional, you know, cloud gaming card. And that's where Render was born, because they would, you know, you'd have 10,000, 20,000, 30,000 GPUs out there among the 3 big data centers, and they were blocked. Like, it cost us way too much to do that. So, you know, 120, 150 million GeForce cards that our customers were already using to do the same render, a lot cheaper. That's how Render got started. When you move towards AI, really the big things are memory and the ability to pull things together, which is important for training, not so much for inference. And I think when it comes to specialized hardware, you know, it's not like NVIDIA. If there's something that if you build an ASIC, and there are some companies like Rockwell that have done this really, you know, efficient ASIC that handles, you know, Facebook's Llama models, for example, and, you know, spits out these tokens at massive speeds. The problem there is that what if things change? Like when you do specialized, you know, video encoding hardware, and you can't, it doesn't scale to do, you know, H.265, you know, or HEVC when that came out. I mean, that's the thing. We have no idea exactly how, you know, LLMs might evolve. They're certainly going to become multimodal, which means they're going to be doing video rendering, take video as input. It's not just going to be text. And at that point, you might still want to have all the other parts that a GPU provides. So I'm always interested in seeing who's got all the pieces to make that work. Another interesting vendor is Apple. I mean, if we imagine a decentralized future that can leverage iPhones and iPads and even Macs, which have, frankly, a ton of memory, and Apple's committed to making as much AI as possible work locally. That's their selling point for future iPhones, and they're taking that very same hardware now and putting it for the first time on the cloud. I think that it's going to be interesting to see whether there are players that can disrupt that with specialized ASICs. It hasn't quite happened. Like Google created the TPU a long time ago, which is a tensor processing unit, and it hasn't really fundamentally dislodged NVIDIA. And I think Apple, if they can scale up their GPUs that are running locally, they're going to need to on the server side, but then that goes into more mainstream Macs or Pro workstations, and you start to see tens of millions of those out there. That could be amazing for the future of what we're all looking for. And then that mixed with the fact that I think a lot of training data is, a lot of training centralization is going to be diffused when you get to a future where you're doing much more during the inference side. I feel that's all pretty positive. And I think to your point too, even OpenAI, I think a lot of their expenses, right? I mean, you're running for $20 a month ChatGPT 4.0, and the audio stuff that they've added is even more computationally intensive. I think they're doing that at a loss. So I think a lot of that, I mean, they're trying to, yes, I think they're losing $14 billion or spending that or something like that. It's all, I think a lot of that's going to inference as well as, these discrete training steps. So, yeah, very interesting transition happening in this space right now.
Yeah, I think just on talking about Apple, like it's interesting to think about, who could really disrupt NVIDIA. Not just on the sort of technology development side, but who actually has the supply chain to like ship hardware. And you think about companies like Grok and Cerebus, and there's a handful of these etched that are kind of making very specific bets. But building hardware is hard.
Very hard.
Building hardware at scale is very, very hard. And so it's not just a question of like can you innovate? Can you actually build this and like ship it at scale in a way that's also like revenue generating and like net profitable. You can't do it at a loss and then still compete with NVIDIA on price and performance and all those things. Like, it's a really big undertaking.
Yeah.
And I think an existing provider like Apple, maybe AMD, they seem pretty well positioned, but I think a lot of the upstarts will struggle.
Yeah, and it's crazy to see sort of how, I mean, where Intel's at, or even AMD. I mean, they haven't really, I mean, they were in this space that, certainly AMD was making GPUs head-to-head with NVIDIA for the longest time. I mean, they have done pretty well, but I mean, they're so far behind in terms of performance on, on generative AI tasks, and heck, even on, on gaming cards, right? I mean, NVIDIA is, basically just one generation ahead. And I know this because when we were doing our software for all the Apple devices in 2020, so we were featured in the Apple keynote because we brought Octane, our renderer, to Metal, which is Apple's API that competes not just with the graphics APIs for games, but also with CUDA, which is NVIDIA's proprietary GPU programming language. And at the first iteration that we launched with them in 2019, it was Intel, AMD, GPUs, right? That was when Apple was still on Intel chips. And then when they switched to Apple Silicon a year later, and we were also featured in the keynote, and we were running all our software again, it was clear that like Apple just destroyed the need both on CPU and GPU for anything from AMD or Intel. And I think they're the ones to watch. I mean, I think that they've adapted pretty quickly. They didn't have ray tracing hardware like NVIDIA did in 2018. That's now, shipping every phone from the iPhone 15 onwards, and those kinds of things mixed with their, they have little neural processors on there. I do think that Apple's pretty motivated, has the resources and the know-how to at least, compete with NVIDIA, certainly on the client side, because I do think that you're going to want to have AIs running locally as well as in the cloud. And what's the endpoint for consumers seeing this stuff? I mean, a lot of people have, started with computers and GPUs for gaming, but I do think that's shifting. And then you also see other types of platforms emerging, right? With stuff that Johnny, I might be doing with the, sort of the Her earbud, right? Do we have glasses? Do we have, AI pins and things like that? Probably, something that's more ambient computing. Those kinds of things might disrupt things further, push things more towards the cloud or the edge. And it's going to be interesting to see how that plays out over the next 3 or 4 years.
Yeah. No, good. Okay, well, switching gears a little bit, just looking at time, I want to get both of your takes on if generalized or specialized models are going to win in the long run. And I feel that there's kind of 3 options. It's that the generalized models beat everything, and you don't even need to fine-tune on top, or then we have these generalized architectures, and then fine-tuned models win. And then there's these smaller models that are super specialized with private data sets that end up being more application-specific. And I'd love both of your takes on what takes precedence.
Yeah, so it's always a matter of like cost versus performance. A generalist model is going to perform well on a lot of tasks, but usually they're quite large. 90 billion parameters, 400 billion parameters, 405. GPT-4 is something like over 1 trillion, and it's expensive to run those models. So if you're doing generalized work, you probably need the extra reasoning power and sort of broad scope, broad ability. But it's expensive. So what you can do is sort of, once you've narrowed your focus, if you're building some sort of application, you can take a generalized model. It can run a bunch of generations and then use those generations to fine tune something on a very specific task, which is going to be more efficient, more cost effective for you to run in the long run. So I think it will be a mix. I think the generalized models will always do better on like your kind of general evals, but you'll have probably a lot of small like task-specific models that you can run for really, really cheap, and they'll be kind of embedded in all the important places.
Yeah, I see that too, and I'll talk sort of in the context of video and media generation, right, image generation, because we've done a lot of work with that, and what we've seen is that, as I said, you're probably going to get to a place where you're going to have LoRa's between specially trained, images or objects or assets on top of a base model. What we're finding is that you don't want necessarily a base model trained on a huge amount of stuff, especially if you're going for something specialized. Let's say you are Lionsgate, right? You just gave all your movies to Runway to basically help them generate shots for the next film, the next Hunger Games for cheaper. But what we found is that if you don't have the base model, even if it's trained with less data, but if it's trained with a broad range of general data, very important. So when you do give it something that's specific, like something that's IP related, it'll do better. And I think that that's sort of where whoever's going to train these base models so that you can run more things at the inference side and fine-tune it needs to get that part right. And it turns out that if you throw a lot of data at something but it's not broad enough, it doesn't really work well. And we're seeing that come out in strange ways. I mean, like video and image generators in AI is a black box, it's magic, it's weird, but we're starting to understand a lot better as we're making tools, right, for artists and creators to leverage this technology, that how that data is trained and how much of that data is trained, it is the quality that you feed it. And I also think that the size and the scope and the cost of all these things is going to go through a whole layer of efficiency, right? Where people have already been quantizing models, figuring out where that threshold matters. But also, I think that a good, when the data is smartly, applied and it's broad enough, and you're moving to a world where you're going to have a lot of stuff being effectively scooped up at inference time to give you that domain-specific work. You do want good reasoning, but that's also where I see at some point the massive training steps sort of, not being as important, and even the data sets being a lot smaller when you're trying to build a general purpose image generator or a reasoning engine, and then the data that you're feeding it for these smaller scale fine-tuning steps at inference, I think, can still work really well. And that to me feels like it's where things are going. Certainly on the media and generative video and AI, and image side, that's proving to be true for the work we're seeing and the research that we're doing at this moment.
You're starting to see more people do this sort of agent orchestration, or you have like an agent system that's maybe a handful of different LLMs, and you have like the big LLMs that are generalized and very smart, and then you have small LLMs that can do very specific tasks, and the smarter LLM is sort of like managing the small LLMs to do different things, and then the small LLMs will pass data back up. So I think it will be a mix, but I do think that the kind of the big production systems that I'm seeing built really incorporate small fine-tuned models and large generalized models.
That's really interesting. Okay, so we'll do 2 fire questions. So the first one is, what do you have the highest conviction in the entire space right now? And then give like the 20-second thesis on it.
I can start.
You can start.
I think the price. I think so inference is priced primarily in cost per million tokens. So a small 8 billion parameter model kind of market price right now is about 5 cents. Part of our thesis is that the cost of inference will come down probably at least 1 order of magnitude and maybe 2 over the next 24 months. There's a bunch of reasons for this. It has a lot to do with the hardware that is about to hit the market, the next generation of hardware that's going to hit the market, just putting a lot of downward pressure on the cost of inference because there is so much supply, and then kind of working more at the software layer to unlock all of this latent compute in the form of consumer devices. I think all that sort of happens at the same time, and the price that developers are paying for inference comes down really, really dramatically.
Yeah, I mean, our hope with the Render Network is we provide, we have 1 million GPUs in our wait list, and a lot of it is, of course, tuned for doing generative media content. But as I was saying before, when you look at how LLMs work and how they're moving to be multimodal and how you have players like Apple that are, they're going to do everything they can to bring some of these things to the local hardware. So in some sense, when inference is good enough on your phone, it's free, right? That's one possibility. And I think on the data center side, if you don't need massive interconnected GPUs, the cost will go way down because systems like Render, we're not the only ones. We were the first to be in the GPU Deepin space by a lot, but now there's other players, and that's great. The idea is that you have competing efforts to try to bring the costs down, but you do need to match that with where all these workloads are going. And right now, CoreWeave is still, is probably a great way to do massive training, but I do think that we're heading more and more towards more efficient models. As you were saying, sort of chaining models together is pretty important, and all those things can happen. And even when we're talking about like live streaming, cloud gaming, these are things we've been doing on Render forever. Mixing those pieces together does feel like you're going to get to a much cheaper cost. And I think you're seeing that already. It takes almost nothing to generate an image. A lot of image and video generating services are really cheap costs. It's certainly almost, maybe they're being subsidized because everybody wants to get users early. But I do think that it's going to be something that's pretty inexpensive on the inference side, and hopefully even to be able to sort of create new types of models without having the kinds of crazy training costs that we have now will evolve as people figure out where these pieces can fit in and how to move more and more towards the inference end of things.
Okay, we'll pause there, just given time. Thank you, guys.
Thank you all.
Thank you.
It's a pleasure. Thank you.
Okay.
Please welcome now Dan Greer.